Ah, all right. Time to get started then. Okay. Writing a simple C++ program. Every one contains one or more functions, one of which must be named main. Our operating system runs a program by calling on main. Here's a simple version that does nothing but return a value to the operating system. Let's change mine to be like that. This is just the default from Visual Studio 2017. Return 0. Save. Run. Should do nothing. Yep. Function definition. Okay. Has 4 elements. Oh, okay. So this is saying this is a function. There's a return type, a name, possibly empty parameter list in enclosed parentheses, like here, and a function body between brackets. Although main is special in some ways, we define it the same way as any other function. In this example, it has an empty list of parameters. The function is required to have a return type of int, which is a type that represents integers. So this 0 is an int because this function is an int. The int type is a built-in type, which means that it is one of the types the language defines. The final part of a function definition, the body, is a block of statements. We're starting with an open curly brace and ending with a closed curly brace. And there's the example. The only statement in this block is a return, which is a statement that terminates a function. As is the case here, a return can also send a value back to the function's caller. So this return will end the function. So if we had, say, this should still just end and give us nothing. Yep. Whereas if we move it, we get our output. Sweet. When a return statement includes a value, the value returned must have a type compatible with the return type of the function. In this case, the return type of main is int, and the return value is 0, which is an int. On most systems, the value returned from main is a status indicator. A return value of 0 is a success, and non-zero has a meaning defined by the system. Ordinarily, a non-zero return indicates what kind of error occurred. Key concept types. Types are one of the most fundamental concepts in programming, and a concept we'll come back to over and over. A type defines both the contents of a data element and the operations that are possible on that data. The data our programs manipulate are stored in variables, and every variable has a type. When the type of a variable named v is t, we often say that v has type t, or interchangeably that v is a t. So, in this case, variable v is a type int. If we were to return v like this, and then this should work. Yep. Because this type is this. And that int v is a int. Has type int, sure. Having written it, we need to compile it. How we compile it depends on the operating system and compiler. I just need to hit F5 here to debug. Is F5 debug? Yes. Start without debugging. Let's try that. Control F5. It just runs instantly. F5, it takes a second. After it debugs and confirms it should run, it runs. Let's try making a mistake and running it without debugging. Control F5. There were build errors. Would you like to continue run the last successful build? Yes, and it just runs the old one. Let's do that again. No, it just fails out. Doesn't let me run it. What if I do this? Control F5. Just there were build errors. Okay, what about debugging? Where do I see? There it is. It's in build. No. So in build it says build started on this project with this configuration. Here's the name of the thing. We go here, and on line 10, oh, I don't have the line numbers on. Where do I change that view? Time to look it up. Tools, options. Text editor. Line numbers are on. So it's on in all languages, but off in C, C++, why? Terrible. Save. So yeah, back down here. On line 10, we have the error. Cannot convert from const character 6 to int. Why is it this and not a string? I don't know. Unless it's counting the characters. Like we have an array of characters and 0, 1, oops. I still shift, not control. 0, 1, 2, 3, 4, 5, 6. 6 characters? Probably. Anyway, we did that on purpose, so now we can just fix it. We wanted to see how the debugger would react. Sweet. Moving on. Many PC-based compilers are run from an IDE that bundles the compiler with build and analysis tools. They're an asset in developing programs, but require some time to learn how to use it effectively. And is beyond the scope of this book. So Visual Studio 2017 and hopefully Visual Studio Code when I get around to fixing how it works with school. That's going to be on my own. Program source file naming convention. Whether you use a command line interface or an IDE, most compilers expect program source code to be stored in one or more files. Program files are normally referred to as source files. On most systems, the name of a source file ends with a suffix, which is a period followed by one or more characters. The suffix tells the system that the file is a C++ program. Different compilers use different suffix conventions. The most common include .cc, .cxx, .cpp, .cp, and .c. In this case, .cpp. Running the compiler from the command line. You're now using command line interface. We'll typically compile a program in a console window. Assuming that our main program is in a file named this, we might compile it by using a command such as $cc name of source file, where cc names the compiler and the $sign is the system prompt. So system, use the compiler, use this particular compiler on this source file. Compiler generates an executable. On a Windows system, the executable file is named sourcefile.exe. Unix compilers tend to put their executables in files named a.out. To run an executable on Windows, we supply the executable file name and omit the .exe extension. And there's a whole bunch of different ways to do this. Running the GNU or Microsoft compilers. The command used to run varies across compilers and operating systems. Most common are the GNU compiler and Visual Studio compilers. Okay, we know how to compile. So, exercise 1.1. Review the documentation for your compiler and determine what file name and convention it uses. Done. Compile and run the main program from page 2. Done. Exercise 1.2. Change the program to return a -1. It's often treated as an indicator that the program failed. Recompile and rerun to see how your system treats a failure indicator from main. Let's try that. In this case, we will just change v to equal -1. Looks like it ignores it, but it does say exited with code -1. So unless there is an actual error that we can code in by changing this integer, say something happens that we know might happen, we could put the, if condition happens, change v to -1, return v at the end, and now we know what went wrong. In this case, nothing went wrong, except for we changed v to -1, and it exited with that code. Cool. Recompile and rerun, blah, blah, done. 1.2, first look at input-output. Let me actually try renaming these things. Rename. And we will name that one primer 1.1. Does naming it change anything? Just down here runs primer 1.1.exe. Change this back to 0. Yeah. Now we want to do a new project, empty project, primer 1.2, right? Let it do its thing. Now we have primer 1.2. So what's different now that I've done this? See, there's me, source, right? Repository. See, here we have our file. Add new file. This works, right? We need to include IOStream, don't we? Hello 1.2. Why can't I debug? Eh? Select a valid startup item. What do you mean? Okay, let's try this again. New project. Instead of it being empty, we want a console application. Yeah, this is... See, I didn't know how to do any of this. So definitely have it console application. See, the difference is nearly non-existent. It's just... Yeah. Okay, so now that I struggled through that, let's look at this. So, C++ language does not define any statements to do input-output. Instead, it includes an extensive standard library that provides input-output. Most examples use IOStream. There are two types named iStream and OStream, which represent input and output streams respectively. A stream is a sequence of characters from or written to an input-output device. The term stream is intended to suggest that the characters are generated or consumed sequentially over time. So stream, string, like pulling on the end of a string or working your way along a string. That's where that name comes from too, I'm sure. Okay. The library defines four I/O objects to handle input. We have the iStream, or an object. We use an object of type iStream named CN. This object is also referred to as the standard input. For output, we use an OStream object named cout. This object is also known as the standard output. The library also defines two other OStream objects, cerr and clog, respectively. We typically use cerr, referred to as the standard error for warning and error messages, and clog for general information about the execution of a program. Ordinarily, the system associates each of these objects with the window in which the program is executed. So when we read from CN, data are read from the window in which the program is executing, and when we write to cout, cerr, or clog, the output is written to that same window. Program that uses that library. And there's an example code here for entering two numbers. Okay. So we have iStream, we have main, we need to prompt our user. We will say, please enter two numbers. And the example code ends the line. So we will do the same. And then we need some variables to hold those numbers, defaulting to 0, comma v2 equals 0. So being able to do this in one line is nice. And then we want to take input, cin, with the what are these called? Greater than less than symbols. These have a better name, don't they? Carets. Left caret, right caret. Because normal caret would be this. It's an operator. Let's see if there's a name for that. I want to use the right word. Name for... What is the name of those operators? Standard name. When not overloaded, left shift and right shift are, and some people call them that even when used with streams, but insertion and extraction. They're also sometimes informally called put to and get from. This operator, I mean, according to the documentation, okay, so they have a documented name, and it's insertion operator and extraction operator. This one is an insertion operator. We're going to insert to the console, I guess, this text, and then we will extract from that console a v1 and v2 variables. We'll get those numbers from the user. Once we have them, we can do some number math with them. So we will do cout. And we will insertion operator to the console. Some text. The sum of v1 and 2 is v1 plus we do, right? We want to also insertion an end line. We're in debug, enter two numbers, 3, 4. The sum of 3 and 4 is 7. Correct. Exited code 0. Sweet. Okay, so this program starts by printing out a prompt to the user, and then waits for input from the user if they enter 3 space 7 followed by a new line. Does that work? Do I do it without space if I just use spaces? 3, 7, 6. It does. So cin will parse this space for me. It'll determine that that's not a number and effectively separate these two numbers itself. Okay, that's good. Okay. Followed by a new line, then the program produces the following output. And then we're going back to the top of our program to discuss the input-output. So including this header file, okay, let's use the right words. I'm repeating words from things I don't actually know what I'm talking about. Let's not do that. The first line tells the compiler we want to include the library IOStream. The name inside angle brackets, IOStream in this case, refers to a header. So every program that uses a library facility must include its associated header. So to include a library, you need to use the include followed by angle brackets with the header file of that library within. Or the header, just the header. Okay, I just stepped away. Alex got home from a meeting at work and doing groceries and stuff. Okay. Where was I? Header files, including libraries. Yes. The include directive must be written on a single line. The name of the header and the hashtag include must appear on the same line. In general, they must appear outside of any function. Typically, we put all the include directives at the beginning of the source file. Okay, cool. We did that. We hopefully understand that better. Writing to a stream. The first statement in the body of main executes an expression. In C++, an expression yields a result and is composed of one or more operands and usually an operator. The expression in this statement uses the output operator to print a message on the standard output. C++ documentation, according to the internet, does not call that the output operator. They call it the insertion operator, but I guess it does the same thing. Output, input, insert, extract. It's kind of confusing because this symbol of less than symbols is the output operator, but it is also called the insertion operator. So you really have to understand that it is inserting to a console or outputting to a console. You gotta understand the context that it's to a console. The insertion operator takes two operands. The left-hand operand must be an OStream object, and the right-hand operand is the value to print. The operator writes the given value on the given OStream. So, okay. Our output statement uses it twice. Because the operator returns its left-hand operand, the result of the first operator becomes the left-hand operand of the second. As a result, we can chain together output requests. So it's equivalent to doing this thing after this one. So it works from right to left. So this one says, okay, here's this object, and we're going to put an end line at the end. And then I say, here's this object, and now that there's an end line there, we're going to put it on that. It's the same in Java. You work right to left through your statements. Each operator in the chain has the same object as its left-hand operand. In this case, std cout. The first output operator prints a message to the user. That message is a string literal, which is a sequence of characters enclosed in double quotes. So it's okay, it's a string. The text between the quotation marks is printed to that standard output. So the insertion operator and the extraction operator, as it says up here, has to work with a OString object on the left. So we couldn't say define a string that way. It's not a no-string, or an OStream rather. We couldn't do string name This is a Java line, by the way. That's why it's not understanding. I don't know how to do this yet in C++. String name equals Michael. Like that. That would work in Java. We couldn't do this, because this is not an OStream. We have to use equals. Second operator prints endl, which is a special value called a manipulator. It has the effect of ending the current line and flushing the buffer associated with that device. Flushing the buffer ensures that all the output that is so far written is actually written to the output stream rather than waiting to be written. So we probably couldn't put something after the end line, like another hello. Right, there's no thing. Let's see. Unable to start. So this, I'm gonna run it without debugging. So I guess I can do after an end line. So it prints this to the buffer. Prints this. It says okay. So by ending the buffer, it's saying okay, take this and print it now, and then go to the next line. And appended on the end of doing that is saying hello, which it did. Weird. Very non-conventional to do that, I bet. Using names from the standard library. So it uses cout in endline rather than, oh, it uses std, so standard cout in endline rather than just doing it without them. So like this. Undeclared identifier. The prefix indicates the names are defined inside the namespace of std. Again, I'm just going to keep saying standard for now. Inside the namespace of the standard namespace, I guess. It avoids inadvertent collisions between the names we define and uses of those same names inside a library. All the names defined by the standard library are in the standard namespace. One side effect of the library's use of a namespace is that when we use a name from the library, we must say explicitly that we want to use the name from the standard namespace. So by writing standard : cout, semicolon, whatever. Semicolon has a comma, right? So that is colon. Writing standard : cout uses the scope operator, which is the 2 colons. So standard scope operator cout to say that we want to use the name cout defined in the namespace standard. Section 3.1 on page 82, which I'm just going to go look at, will show a simpler way to access names from the library. So using is a declaration to access names directly. Okay. So we can use, by declaring using standard scope cin, cout, and nline, we can then call them without stating it every time. Okay. Okay. So we previewed the simpler way to access names. We'll forget it for now, but we know it exists. Reading from a stream. Having asked the user for input, we next want to read that input. So first we define the variables. Then we get the input from the user using standard scope cin. So standard namespace, scope operator, cin, and then extraction operator into the variables we just created, v1, v2. In that order, I assume. Yes, because that's how it prints out. The extraction operator, or the input operator, behaves analogously to the output operator. It takes an iStream as its left-hand operand, and an object as its right hand. So we can't say cin and then a value to input, I don't think. So I can't say 56 because it wants an object here. And if I debug it, hopefully it says as much. So no operator found in which takes a left-hand operand of type iStream. Note that basic iStream blah blah. There's a whole bunch of different types or ways to, what's it called, overloaded operator or objects. And these are all the kinds built into the standard library, right? Yeah, just line 10, there's a whole bunch of problems while trying to match the argument list. Yeah, there's nothing where it takes an iStream on the left and an int on the right. So basically we need to, when we take input, we need to have containers prepared. And nothing else. You can't, like this is filling. These are filling, and these are containers. Okay. Okay. Where were we? Reading from stream. The extraction operator, or the input operator, behaves analogously to the output. It takes an iStream on the left and an object on the right, reads from the right. No. It reads data from the left and stores it on the right. So information moves along these operators in the direction of the arrow. Information is moving from this space to the right of the arrow, along where it's pointing, and into this. That is the flow of information arrow. And it is flowing from the user into this one first, and then this one. And it is smart enough to understand that spaces separate them. Okay, so we're not always reading right to left, we're reading along the arrows. Because the operator returns its left-hand operand, we combine a sequence of input requests into a single statement. Our input operation reads two values from Cin, storing the first in v1 and the second in v2. In other words, it is the same as This is the same thing as just taking them in one line. Okay. Completing the program. What remains is to print our result. This statement, although longer, is conceptually similar. It prints them on the standard output, and it performs an arithmetic expression. Sweet. We're done with section 1.2. Now on to the exercises. Right here. I'll write a program to print hello world on the standard output. Okay. Let's just do this. And we'll say this cout information is going out, and it will say as the textbook says in the same formatting. And we want to close the buffer. And run. So our original program, followed up by, let's actually print that too. Cout. So now we can see there are sections, and we can copy paste these. Exercise 1.3. Now we'll do 1.4. And then 1.4 says, uses the addition operator to add two numbers, write a program that multiplies to print the product instead. Okay, well that's going to be the same exact program as above. We'll ask for two numbers, we'll take those two numbers in, we will fix our thing to say product, and change the operator, and run. Ooh, it's because we declared the variables again, I bet. Let's actually debug it. I want to see what the debug is. So line 20, we have here redefinition, multiple initialization. Line 9, note, see this. Oh, so it's just telling me, okay, hey, here's the error, and here's where it was first done. And then these operators on line 21. So what happens if I just take that out? Okay, it runs. 5, 5, 5, 6. Okay, so it's working now. Sweet. And there's 2 more exercises. We'll do 1.5 now. We wrote the output in one large statement. Rewrite the program to use a separate statement to print each operand. So a separate, so basically you want it to end after each one of these. We only want one of these. I'm actually going to use 2 so that I can end line, but okay. Alright. So that's going to be, I mean, I don't want to do this, so I want to just do the whole thing again. Not really. Let's just do the last line again. The product output with separate lines, the product of three, 4, 5. Actually, I need 6. So here we will say B1. Here we will say and V2. And then is V1, V2. That should just work, right? Okay. End lines creates a new line as well. So we actually don't want to do that. If, say, we do it like this, then it should work, right? And it does. Sweet. Moving on. And exercise 1.6, explain whether the following program fragment is legal. If the program is legal, what does it do? If it's not legal, why not? How would you fix it? Well, I feel like it's cheating to just see what the debugger has to say about it. So, let me put it in as a comment. And go, whether or not this is legal. And I don't think so. It ends the line here. In order to make it legal, you would need to restate this before each of these, or rather after each of these. Right? If the program is legal, what does it do? Well, if this worked, theoretically it would do the same thing as the last line up here. It would say the sum of v1 and v2 is the sum. And now if I uncomment, we see some squiggly lines, run it, syntax error, lines 35 and 36, failed. And it doesn't say why, but I'm quite sure. And to prove it, there we go. 3 and 4 were entered as product and kept for the sum at the end here. It did the same thing as before. Although the formatting that the book uses is different than what I used. I like the colon here. Okay. Alright, sweet. Well, that ends 1.2. Take a break. Let's make 1.3 first, and then I'll take a break. 1.3 should be fast, and we'll go straight in from there into 1.4. 1.4, however, is multi-part, so we'll probably do, yeah, 1.4, 1, 2, 3, and 4. Each as separate things. Cool, 1.3 is ready, and I'm going to come back in a bit. Okay, I'm back. Whew, section 1.3. Alright. I'm gonna start using my timer. 50 minutes on, 10 minutes off timers. Okay, study 50 minutes, start. Alright, section 1.3, comments. Ooh, let me put that back over here. Comments are for readers of the program. We know that. / or / star. We know that. It's familiar from Java. Python does it the same, I believe. Okay. In this book, we italicize comments to make them stand out. In actual programs, it's distinguished based on the programming environment. In this case, our comments are green. Comment pairs do not nest. That makes sense. Okay, so what it's talking about is, and I will just type out the comment the same way they have it. Oops. And we can see already as I'm typing this that it's not green anymore. So these types of comments with the, what are they called? Multi-line comments. They start with this combination of symbols and end with this combination, which means you can't put a comment with multi-line comments inside of it like this. Can you do single line? Yeah, no problem. But you can't do it like this because this says a start comment, 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 end comment, and then the rest of this is just code in the code. And obviously we're going to have significant errors trying to run like this. We often need to comment out a block during debugging because that code might contain nested comment pairs. Because that code might contain nested comment pairs, the best way to comment a block of... Oh, okay. So like if I had a bunch of code, and then like more code underneath that, and there's this comment inside this, and I want to comment out all of this, the best way to do that is like that, because then you can have comments inside without errors. And that's it. 1.3 is done. But let's see. Exercises: compile a program that has incorrectly nested comments. I mean, here I will recreate the problem from before and run without debugging. And it's just like, no, can't do that, it fails. Indicate which, if any, of the following output statements are legal. Well, I'm not going to create exercise sections like I did for 1.2, but standard cout. Can you put that in comment or in quotations? Probably, actually. And even if you couldn't, what's it going to do? It's going to start a comment here that runs to here. And then cout is just going to print out an empty space, or actually no space. It's just going to start a line. And that'll still compile. And then this line is cout, comment, end line. See, without the quotes, I'm pretty sure this is just going to become a comment. So is that an error then? Because the, what's it called? The output operator wants a value to send to the OStream object. I mean, let's just try these, I guess. Oops. That was legal, right? I want to catch that comment. Yep, seems totally fine so far. But then once we start going to this, yeah, he catches this as comment and then it gets confused. It's really kind of trolly, isn't it? Like, really, this line is the only one that's broken. Because it's trying to make you think that this is the thing that's being in quotes, but really this is the thing in comments and this is the thing in quotes. So this should run just fine. Yeah. See, there's no new lines, but it's like start and comment, right? And then down here we have space start comment, space. There's an unseen space here. And then end program. Yeah, it's just trolly. Okay, new project. And this will be primer 1.4.1. Because 1.4 is just this, and then 0.1 we get into the while statement. So 1.4 is flow of control. It says statements execute line by line. Very few programs, including the one to solve our bookstore program, can be written using only sequential execution. Instead, there's flow of control statements that allow you to iterate through things repeatedly. So if, while, for, in this case, let's see what we're actually getting in section 1.4. We're getting while, we're getting for, if, and that's it. And then after that we start classes. Okay. So a while statement repeatedly executes a section of code as long as some condition is true. The testing condition here is that value is less than or equal to 10. So let's start copying code. And this will be sum equals 0 and val is equal to 1. There's a comment in here telling us how the code works, and it says to keep executing the while as long as val is less than or equal to 10. And and it's describing this next line. So while val is less than or equal to 10, there's some scope. In that scope, the sum will increment by value and there's a comment here that says assigns sum plus val to sum. So this is the same thing as saying sum is equal to sum plus value. So we're going to start with 0, and val will be equal to 1. And during our first loop, value is 1, so it is less than or equal to 10, and sum will be rewritten, and it'll be overwritten, not as 0, but as 0 plus 1, so 1. Right? And if we just left this, it would run infinitely. And in fact, we're seeing is taking up processing and memory to run, and that's what it's doing. Now, we don't want it to do that forever. So our next line is immediately after each increment of value, of sum that is, every time right after we add value to our sum, we're also going to increment value by 1, which means it should run 10 times. Or 9 times. And in fact, I would like to see it happening. So I'm going to add my own code here that says cout sum. And end line. Okay, so we have 0 plus 1 is 1. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. And that is the end. So that's just to see it happening. But the given code says we're going to check the output, but only at the very end. And it's going to say sum of 1 to 10 inclusive is 55, and that's what we saw, right? We saw it incrementing. Now, can we step through the code like I do in Java? Analyze. Tools, debug. Step into. Let's try that. Debug. Step into. And we're at line 7. How do we increment steps? Continue. Oops. Debug, step into. Next statement. Okay. So now we've created these values and they're currently some abhorrently negative number. By the time we reach this line, They are now set to the appropriate number. And we want to step into oh, okay. F10 is the next step. And we can watch down here as our variables change. 3, 3, 6, 4, 10, 5. This is what it means to loop. And we can see them doing the things. We tell them one at a time. And now that so this is going to keep going as long as the value is less than or equal to 10. So right now it's 10. So we're going to add 10 to 45. We're going to increase this to 11. We're going to end the scope here, and then we're going to recheck again, come to value, and then it should come down to this one, because it sees, okay, that's false. Yep. And then over here, I hit it. There it is. Hit it again. Still there, hit it again. There we go. Okay, so debug step into. Okay, that was a little bit of a thing. Okay. When we compile and execute this program, it prints this, yes, as before. We include the IOStream library. We define our variables. And then we sum up those variables and continue through the loop. I know how a while statement works. Less than or equal compares. So the plus plus operator adds 1 to its operand. And it's the same as writing value equals value plus 1. In other words, what it's saying is like exactly how I described it earlier, but what I'm taking away from this is like what I already know, but I'll restate it. When you create a while loop, you need to have an out. There needs to be some way for this condition to become false. Otherwise, it'll run forever. Okay, exercise, yay! Write a program that uses a while to sum the numbers from 50 to 100. Okay. So let's do int a equals 50. While a is less than or equal to 100. a... I am gonna need two variables like before, huh? Yep. Sum the numbers, so we need to have b equals 1. Yeah. And then we do a plus equal b plus b. And I can take this output, change it to 50 to 100. The sum of 52, 100 inclusive is 55. Oh, wow. It should be not sum, but a, right? Well, that's going to be 50 plus 55. What am I doing wrong here? While b... No. Oh yeah, we do want it to be b. There we go. That looks more like it should be the right number. Because it should be pretty close to like 50 times 50, right? No, because 50 times 50 would be 250, 2500. Why is this not right? The correct answer should be 3825. What are we doing? We're summing 50 plus O. So we're saying, okay, now 50 plus 51. And we keep going until... There we go. 3825 is what we're looking for. Yep. Now we got it. Okay. Section, or exercise 110. In addition to the plus plus operator that adds 1, there is a minus minus. Use the decrement operator to loop and print the numbers from 10 down to 0. Okay. And C equals 10, while C is less than, or rather greater than or equal to 0. We want to print out C. And decrement C. There we go. Easy. And now we do 111, which says write a program that prompts the user for 2 integers. Print each number in the range specified by those 2 integers. So if I ask the user to print, or to say 2 integers, and they say 5 and 10, print each number in the range specified by those 2 integers means print 5, 6, 7, 8, 9, 10. Okay. So we're combining input output, or rather just input, because this is the only thing that's new. Let's do first prompt the user. See out. Please input 2 integers. Now we need, we'll say x and y. Int x equals 0, y equals 0. And now we want to take those. Let's make a z as well, a counting one. which we'll set equal to, actually we'll do it after. To make it resistant to putting them in the wrong order, so like I think the easiest way to do this is assuming the left-hand integer is smaller than the right-hand, but necessarily that's not going to be the case, or that's not necessarily going to be the case. So let's do it instead like if, we'll use an if statement, even though we haven't been taught them yet. If x is less than y, less than or equal to y, then while x remains less than or equal to y, which it won't for long because we're going to do things to x, then cout x, and increment x. Else, we actually don't need a statement, that just means it's the other way around. While x is greater than or equal to y, and this time we will do the same thing, but we're going to decrement x, like so. And we'll do 5 and 10. And now we'll do 10 and 5. And it counts down. It counts up or down. Let's try larger numbers. 1 and 100. Count it up to 100. Give me negative numbers. Negative 50 and 0. Yep. Cool. Sweet. What if it's the same number? 5 and 5. Yeah, works. And that's the end of 1.41. So let's make a new project and go to 1.42, or 1.4.2. for statement. I'm going to get this code in here and move the textbook back. So, in our while loop, we use the variable val to control how many times we executed the loop. Tested it in the condition and incremented it in the while body. This concept happens so often that the language defines the second statement, the for statement, that abbreviates code that follows that pattern. We can rewrite this program using a for loop to sum the numbers from 1 through 10 as follows, and here's the code for that. Okay, yeah, I mean, we got the same result as before, as we should, but we see that the for loop does the same thing. Okay. Maybe, you know, it's really late into this first stream to be doing this, 2 hours 10 minutes. But I wonder if I can unlock this webcam and transform. I can. And now you guys can see without it being upside down. See, I don't use OBS much. And I didn't prepare super well for this, but yeah, this looks much better. Hopefully showing a textbook on stream is fine. Like, this font is so small nobody can read it anyway. Not that anyone's going to watch to begin with. Okay. So, we define sum, initialize it to 0, define val as part of the statement. For each for statement has two parts, a header and a body. The header controls how often the body is executed. It consists of three parts: an init statement, a condition, and an expression. So initialize the value, set a condition based on that value, and an expression to change that value so that eventually that condition will be met. And that's what this next page says. To recap, the overall execution flow of this for loop is to create a value, initialize it to 1. Test whether it's less than or equal to 10. If it succeeds, execute the body. If it fails, exit and continue with the next line. Step 3, increment the value. Step 4, repeat step 2 until it fails. repeat from step 2. Yeah, until you leave the loop. Okay. Exercises. Damn it. Uh, 1.12. What does the following for loop do? What is the final value of sum? So set sum equal to 0, int I equals negative 100 until from I. So until I is greater than 100, increment I. Or add the value of I to the sum. So it's going to say sum, add negative 100. And then sum will be negative 100. And then it's going to be sum, add negative 99, negative 199, add negative 98, and negative 200 something. And it's going to be a very negative number until we start adding the positive opposites, which means if you're adding the entire range of negative 100 to 0 and the entire range of 0 to 100 all together, you should have them all cancel out and have the final sum be 0. Let's do that. So sum back to 0, and we will do for int I equals negative 100. Where I, until I is greater than positive 100, increment sum plus equal I, and then should be just like this. It should be 0. Yeah. 0. Sweet. Uh, 1.13. Rewrite the exercises of 1.4.1 using for loops. No. I mean, I don't want to do that. Too easy, too easy. An input? Okay. We'll do an input. We'll do a range of inputs, like we did before. That's the one that was not as trivial. So if I want to do that using for loops, we'll still need to do prompting of the user. Oop. There's my study timer. I need to take a break. I have a break timer. So I'm actually going to just stop here with this line. and come back to it in 10 minutes. Actually, I'm noticing now that my voice is getting very tired. I don't normally speak this much in a day. I know it's only been a couple hours, but this is new to me, and it's making my voice sore. So, in an effort to not have that ruin everything going forward, I'm going to stop the streaming thing, or at least the speaking part. Yeah. I'll resume the timer. But let me share. I'm gonna turn this on then. Obviously, doesn't belong to me. Um, so let me fix my desktop audio. Properties. There we go, now you can hear the music. And I'm gonna mute myself.